This is the third and final section of the dynamic programming chapter, and in this section we're going to be looking at dynamic programming problems in table form. Now, since these dynamic programming problems in table form are often worded, it's really helpful to be able to, at the very start of the question, identify what the stage, state, action, destination and value are in the context of the question. Now, here's some sort of hints that may help you. So stage is usually some sort of time span. It's like a month or a year, something like that. The state is what resource is left. The action is what resource is made or used in a particular stage. So the state will be what resource is left in a particular stage. And the destination is what resource is then carried forward to the next stage, or actually the previous stage. It'll be like the previous number. So this may help you in identifying what these different parts are, and the value that's just going to be your profit or cost, that type of thing in that last column. And you'll need to just think carefully about how you work out those values. You can have a look in the examples that I'll be doing in a moment. And yeah, remember with dynamic programming we work backwards from the end result back to the beginning, and you may need to use dynamic programming with these types of problems in table form to solve or to find the minimax or the maxi min. Example 7. A fruit grower can use his surplus crops to make into jam, pie filling or dried fruit. He can process up to 5 units of fruit, and the expected profit in hundreds of pounds from making various products as shown in the table. So that's this table here. He will use all 5 units to make these products and wishes to maximize his income. We're going to be using dynamic programming to solve this problem, but in part A we've got some definitions to do, and what we need to do in part A is to define the terms stage, state, action, destination, value, and they need to be in context of this question. So we'll start with stage. Now, in the context of this question, the stage is the product that's under consideration, and that's either the jam, the pie filling or dried fruit. Next is the state. This is the number of available units. Then action. This is the number of units allocated to one of the products. In other words, the number of units that we either allocate to jam, pie filling or dried fruit. Next is the destination. This is the number of units remaining, i.e. the number of units that are going to be passed on to the next stage. And lastly, the value. This is the cumulative profit, and in this particular example we want to maximize this profit. Okay, so on to part B. Determine the number of units he should allocate to each product in order to maximize his income. Okay, so let's label up this table. Okay, so we've already defined these in part A, so we should know what these mean. So the stage is the product that we're going to be considering. So starting at the bottom of the table, so remember dynamic programming, we start from back and work backwards, or from the end and work backwards, from the sink and then work towards the source. First one is going to be dried fruit, so stage 1, dried fruit, and we'll think about the different options that we have. So first of all, how many units could have been passed to the dry fruit stage from the previous stages? Well, maybe all 5 units have been used up and there's none to pass on, or maybe 4 units have been used up so there's 1 to pass on, 3 units have been used up so there's 2 to pass on, 2 have been used up so there's 3 to pass on, one has been used up, or maybe none have been used up. Now, because we're at stage 1, which is the last part of the sort of network in this dynamic programming problem, we always need to make sure that we end up with none in the destination. So there should be none left at the end. That means that my action is going to be using up whatever units have been passed on from the previous stages, like this. Then I'm going to work out what their values are, and this is where the table comes in. So I'm now considering the dried fruit, and the table tells me what the costs are, or the profits are, for different units of fruit being used up. So for dried fruit, obviously if I'm not using up any units, its value is 0, so I'll just put 0 in. If 1 unit has been used, then its cost is 8, 2 units 16, 3 units 24, 4 units 32, and all 5 units 40. Now we always, in these problems, either want to work out or put an asterisk beside the maximum or minimum value for each state. So each state only has 1 value. So all of these need to be starred because this is going to be the maximum. So remember that each state, we're looking in this case for the maximum value. Since there's only 1 value, that's the maximum. Okay, so that's stage 1 complete. We can now move on to stage 2, and stage 2 is the pie filling. That's the next stage. So just like before, we need to consider what all the options are. So when we get to stage 2, it could be that there are no units that have been passed on from the previous stage. So this would mean all 5 units have been used up in the jam filling stage, which means then there are no units to process, no action to take. So there'll be none to pass on to stage 1, the dried fruit stage. So we're going to work out the cost. So if there's no action, that's going to be a cost of, or value of 0, plus passing on 0 to the next state, we want to find a maximum value, and that's the starred value there, which is 0. So 0 plus 0 is going to give us 0. Okay, so that is going to be the only value for a state of 0 in stage 2. So that's going to be an asterisk. Okay, the next option would be that 1 unit has been passed from the previous stage, the jam filling stage. So this would be where 4 have been used up in the jam filling stage, 1 left, passed to the pie filling stage, and we have 2 options. That 1 unit could be used, and then there's nothing to pass on to the next stage, or that unit may not be used and then pass straight on to the next stage, or to stage 1. So we're going to consider both of these options and work out the cost. So now for this state, there are 2 different values and we want to select the maximum one. So let's start with this one. And for this, we will need the middle row of the table, the pie filling row. So we've got the profits there for different units being used. So here we're using 1 pie filling unit. So that would be a profit of 16. If I've been saying cost, I mean profit. So it's a profit of 16. Plus, if I'm passing on 0 to the next stage, that would be here. Then that would also be, well, it wouldn't also be, but that would be a value of 0. So that's 16. Now I don't star this yet because I need to work out what is the value of this. So no units used in this state, that would be 0. 1 passed on to the next stage, okay, and that will be a cost of 8, or value of 8. So that gives me overall 8. So the maximum from those 2 is going to be the 16. Let's move on to the next option, which would be that there are 2 units available from the previous stage. And if that's the case, if 2 units are available, either those 2 units are used up, which means that there's none to pass on to the next stage, or one of those units is used up, so there's 1 to pass on to the next stage, or, and we'll go up to this part of the table up here, so we'll carry on from here, it may be that none of those units are used up, which means that there's 2 to pass on to the next stage. Okay, so if we continue, if I use up 2 units in the pie filling stage, that's going to be 18, cost of 18. Oops, that needs to be in blue, 18. And then none to pass on to the next, so it's going to be 0, so 18 plus 0 is going to be 18. Remember, we don't start this yet. We need to work out what all 3 of these costs are, or values are, for this state. I use up 1, I pass on 1. So if I use up 1, that's 16. And then if I pass on 1, that's going to be 8. So 16 plus 8, that's going to be 24. And then up here, if I use none and pass on 2, so if I use none, that's going to be a value of 0. And then if I pass on 2 to use here, that's going to be 16. So 0 plus 16 is going to be 16. I star the highest one, and that's going to be the 24. That's here. Moving on, we could have 3 units available that have been passed on from the previous stage, and our options are use up all 3, pass on none, use up 2, pass on 1, use up 1 and pass on 2, or lastly use up none and pass on all 3. So let's work out what the values of these are. So if I use up 3 units in the pie filling stage, that's going to give me a profit of 20. So that's from this part of the table. So using up 3, passing on none. So if I use up 3, 20, I know that in the next stage, if I've got none to process, that's going to be 0. So 0 plus 20. If I use up 2 units, that's going to be 18. And 18 plus what 1 unit would be in the next stage, and that is 8 just here, so 18 plus 8. And if my maths is right, I believe that is 26. I could use up 1 unit in this stage, which would be 16. So it's going to be 16 plus, and then 2 to pass on to the next stage. That will be 16. So 16 plus 16 is 32. High so far. Let's keep going. Or I could use up none in this stage here, or in this state of 3, which would be 0. And then pass on 3 to the next stage, which will be 24. So 0 plus 24 is going to be 24, and the highest of those is the 32. Next will be a state of 4. Use up 4, pass on none, use up 3, pass on 1, use up 2, pass on 2, use up 1, pass on 3, use up none, pass on 4. So 4 and 0 would be 22 plus 0. 22 plus 0, which is 22. 3 and 1, using up 3, pass on 1, would be 20. And 8, so 20 plus 8. 20 plus 8, which is 28. 2 and 2, using up 2, would be 18. And passing on 2 would be 16, so that's going to be 18 plus 16. 18 plus 16, that's 34. Using up 1 here would be 12, and then passing on the 3, so 12 plus 24, 12 plus 24, which is 36, and then using up none and passing on 4 would be 0 plus 32, so 0 plus 32, which is 32. And I've just spotted an error here, so if I'm using up 1, actually it should be 16 plus 24, not 12 plus 24, so let's correct that. So 16 plus 24, and that will give 40. So that I don't think it changes which one I was going to star, but it definitely changes the value. So it's going to be the 40 that I star. That gives us the biggest profit. Okay, moving on to the next state, which would be 5. So there are 5 units available. So we could use up all 5, pass on none, use up 4, pass on 1, 3, 2, 2, 3, 1, 4, or use up none and pass on all 5. Right, let's work out the values. So 5, 0 would be 24 plus 0, which is 24. 24 plus 0 is 24. Then next one down, which is going to be 4, 1. So 22 plus 8, which is going to be 30. 22 plus 8 is 30. Next one down, use 3, 20, pass on 2. It's going to be 16, so that's going to be 20 plus 16, which is 36. 20 plus 16. Use 2, pass on 3, so if I use 2 that's 18, and if I pass on 3 that's 24, so it's going to be 18 plus 24. 18 plus 24, which is going to be 42. And use 1, 16, pass on 4, so 16 plus 32. 16 plus 32, and that's going to be 48. And then lastly, use up none, pass on 5, so that's going to be 0 plus 40. 0 plus 40, and so that will be 40. And I can see that from that state, the highest profit is going to be 48. So that now completes stage 2. So all the way down to here. And we'll move on now to stage 3, which is the jam. So in this last stage, none have been passed on from the previous stage, or I suppose 5 have been passed on. That's the only option, and our options are to use some or none of them, and we can then use this to go back and then see what those values are going to be. So if I use up all 5 units in stage 3, there's going to be no units to pass on. So the cost of that is going to be 38 plus 0, because if I go back here, 0 to pass on, 0 to pass on. So it's just going to be 5 plus 0, which is 0. 5 plus 0, 0. Sorry, not 5, 38 plus 0, sorry, my numbers mixed up, so 38 plus 0. Or if I use up 4 of those units, I will have 1 to pass on, or if I use up 3, there'll be 2 to pass on, and so on, like this. And we'll work out these values here. So if I use up 4, that will be 36. Plus, I'm passing on 1, so where's the maximum profit? If I pass on 1, that's going to be 16, so that will be 36 plus 16. So 36 plus 16, that's 52. Next one, I use up 3, so that'll be 33. So 33 plus, let's see what that's going to be. So I'm passing on 2. So if I pass on 2, what's the maximum if I pass on 2? 24. So 33 plus 24, I believe, is 57. If I use up to, that's going to be 27, plus passing on 3 to stage 2. So if I pass on 3, that means the maximum is 32. So 27 plus 32, which is going to be 59. If I use up 1 unit in stage 3, that will be 12. 12 plus, then I've got 4 I'm passing on to the next stage, or stage 2, and the maximum there is 40. So 12 plus 40, which is 52. Or I can use up no units in stage 3, in the jam stage. That means there's going to be no cost. I'm passing on 5 to the previous stage, stage 2, and the most I can get is 48. So that's going to be 48 there. And I'm going to star my maximum here, which is 59. So first of all, let's see what our maximum profit here. Here's 59. Now it does say that these prices are in hundreds of pounds. So we times that by 100 and we get a profit of £5,900. And now we need to state what that allocation is going to be. I've highlighted the route that's given us this maximum profit. And the allocation, well, we just look at the numbers in the action columns in that route that we've taken. So jam, I've allocated 2 units and passed on 3 out of the 5. So jam is going to get 2 units. 3 were passed on to pie filling, and in the pie filling, out of those 3, 1 was used and 2 were passed on. So pie filling 1 unit, and because 2 were passed on, those last 2 were used in the dried fruit stage here, and they were used up. So dried fruit, we would have that as 2 units, and that would maximize this person's profit at £5,900. Example 8. A clockmaker makes grandfather clocks during the winter. The order books for the clocks over the next 5 months is shown in the table below. So we've got a month and how many clocks are required during that month. Clocks are delivered to customers at the end of each month. He can make up to 4 clocks in any month. So he can make up to 4. Okay. But if he needs to make more than 2 in any one month, he will need to hire additional help at a cost of £500 per month. So if he needs to make more than 2 in any month, he will need to hire additional help. So he can make either none or 1 clock or 2 clocks without having to pay this additional cost, but more than 2, so 3 or 4, 4 is the most he can make, he's going to have this extra higher cost to pay. The overhead costs are £300 in any month work is done, right? So the overhead costs, that's like his fixed costs, and if he's doing work, that's going to cost him £300 in overhead, so like electricity, gas, that type of thing, I guess. And if he does no work, there's going to be no overhead costs, and it's going to cost him £300 whether he makes 1 or 2 clocks during the month. If he makes more than 2, then he's going to have his overhead costs plus the additional help costs to make 3 or 4 clocks. He can put up to 2 clocks in storage at a cost of £100 per clock per month. Okay, so he can make more clocks than he needs for a particular month and then put some in storage, but he can only put a maximum of 2 in storage, and there's a cost of £100 per clock. So you can store 1 clock 2 clocks, or maybe that he may not store any, so he could make more than he needs in one particular month and then carry that forward to the next month. There should be no clocks in storage at the beginning of October. Okay, so we must start with no clocks. There's no clocks available, and there should be no clocks in storage after the February delivery. So when he gets to the last clock here that's been delivered, there shouldn't be any left at the end. Use dynamic programming to determine the production schedule that minimizes, so this is a minimization problem that minimizes the costs. Okay, so I've filled in the table with the headings, and I thought it would be helpful to write down the meanings of these headings in the context of the question, even though this question doesn't ask for the definitions, but it will just help us get our head round the problem. So the stage is the month. The state, that's the clocks, the number of clocks in storage from the previous month, so we can make excess clocks in a month, probably at excess cost, and then or extra cost, and then pass those clocks in storage to the next month. The action is going to be the clocks made in a month, so each month we can make some clocks. We can make up to 4, up to 2 without the additional hire help, and then 3 and 4 clocks with this extra hire help. So that would be the clocks made in a month or in a stage. The destination, that's the clocks that are put in storage at the end of the month and passed on to the next month. And the value is the cumulative cost. And then in this question, we want to minimize that cost. So we'll start with stage 1, which is going to be February. So let's think carefully about what the state's action and destinations are going to be. So we don't want any clocks left at the end, so the destination or destinations are going to be 0. Now what are the options? Well, we could have a maximum of 1 clock that was in storage. So remember, the state is the clocks in storage from the previous month of 1. Now why 1 and not more? Because we only require 1 clock in February. So if 1 has been brought forward from the previous month, we don't need to make any clocks. There'll be none in the destination because we've basically sold that clock, that's from the order. Or there may be none in storage from the previous month, which means we need to make one during February, and again that will be part of our order anyway. So let's work out these costs. So a state of 1 means 1 in storage from the previous month, so that's going to be £100. It's £100 per clock. I don't need to make anything, so that's my total value, total cost, and that's the only option for this state, so it's going to be 100. If none are put in storage from the previous month, so that means that there's going to be no storage cost, but there is an action cost, which means I need to make a clock and I need to pay the £300 overhead because I'm doing some work, and so that's going to be 300. And again, for this state, this is the only option. So actually that completes stage 1. So we can now move on to stage 2, which is January. Now when we get to January, we basically want 3 clocks ready at the end of January, and then maybe even have some excess, so we've got some for February. So we could have some excess from the previous month. We can have more than 1 in storage, so we could have 2 in storage from the previous month. We can make 2 clocks, which means now we have a total of 4, which means we've got enough for January and enough for February. So we'll have to put 1 in storage and then carry that forward to the next month, which means then in the next month there is no clock making work to do because you've made enough from the previous month. So this is going to be a storage of 2 clocks from the previous month. Okay, so that's going to be £200. It's £100 per clock. Plus, we're making 2 clocks, so that's going to be our overhead cost of 300. And then we're going to have the storage cost of this 1 clock that we're carrying forward to the next month, and actually that's included here, so we just get the 1, we carry on here, and that's going to be 100. Now I'm going to rub out my working only because I don't have enough space, but I can see that this gives a value of 600. So I'll just rub that out and we'll put 600 in. Now the other option with this state is that we don't make 2 clocks, we don't make more than we need and then have nothing to do in the next month, that we only make 1. So that's going to be enough for January, 2 in storage and 1 that we make. We're still going to have to make 1 in February because we're not carrying forward any to the next month, and that would be this row here. We look at this value here. So still 2 in storage, which is going to be £200. My overheads, because I'm still making a clock, but this time I'm only making 1, but my overhead cost remains the same whether it's 1 or 2, so that's plus another 300. And if I have this destination, I then go to the next state here, up here, so 0, and then here's the 300, which is basically the clock that I make in February. Remember, this is cumulative, so we work out 200 plus 300 plus 300, so that's going to be 800. Now there are no other options for this state, so I'm looking for the minimum cost, and that's going to be the 600. The next state is that there was only 1 clock in storage from the previous month. Now if that's the case, what are my options? Well, I can make enough for January and February, so I could make another 3. I can make up to 4 if needed, which does mean I need to put 1 into storage for February, or I can just make the 2 that I need for January and then I don't have to put any in storage. Okay, so let's now work through this cost. So I've got 1 in storage, so that's going to be £100. I'm making 3 clocks. Well, it's going to cost me £300 to make 2, but because I'm now making 3, I need to hire this additional help, so it's going to cost another 500, and that means I've got 1 carried forward into February. So if I carry that forward and look at the state, that's going to be another 100. So again, I'll work this out and rub it out, but when you do it in the exam or any paper, don't rub it out. So this will be exactly 1000. And the costs from this row here, well, it'll be the 100 from the storage, the 1 that I've had made extra from the previous month. I'm going to make 2, so that's just going to cost 300. I don't need to hire any additional help, which means I'm carrying forward none to the next month, which means I need to add another 300, so the 0 we just carry on here plus 300, and that gives a total of £700 for that month. 700. Now there are no other options for this state because I can't go down to 1 and only make 1, because I need at least 3. Whereas in previous problems we'd go right down to 0, you don't have to use that resource. I have demands on my resource which must be met, so I can go above 3 when you add these 2 numbers together. For January and February I can actually go up to 4, but I can't go below 3, so I can't put 1 down here, because you think about it, I'd end up with -1 here. So from this state I pick the lowest cost, which is going to be 700. Then the next option I have is that there were none in storage from the previous month, which means I can make up to 4, which means I'd put 1 in storage for February, don't have to do anything in February, or I could make 3, enough of what I need for January, and have none carried forward to the next month. So in February I would have to make that clock. So let's work out the costs. So there's no storage cost, there is an action cost. If I'm making 4, my overhead plus the additional help, so it's going to be 300 plus 500. Then I'm putting 1 into storage, so that's going to be a storage cost of 100. And then I take this state forward to the next stage because they're well, I've already included it here. So yeah, so from there, that storage cost, that's the 100. So that will be my total cost. So I'll rub it out because of lack of space, 900. Or my other option is no storage cost. I guess I could put 0 plus. I won't be able to do that. Make 3, so overhead and additional help, 300 plus 500, and doing it the proper way, 0 going across here, that's another 300. So that's basically the cost of making a clock in the next month, because I haven't got any excess here, and that will give me 1,100. So we'll just put that in, 1,100. Right, there aren't any other options in this state, and I'll take my lowest cost, which is going to be 900. So now I will move on to the next stage, stage 3, which is December. Right, so in December I need 5 clocks to be made. So what are my options? Well, I can have up to 2 in storage from the previous month. I can make up to 4 clocks. Okay, that would meet December's demand, and I'll have 1 to put into storage into the next month. Or I can make 3 clocks, which means I have none to put into storage for the next month. But remember, the state and the action need to add up to at least 5, so I can't go below this. As I said, you'd end up with a negative here. So I'll work out the costs. So if I've got 2 in storage from the previous month, that's going to be 200. Plus I'm making 4, so that's going to be 300, my overheads and the additional help. So that will be 300 plus 500, plus the 500. And then the 1 that we put into storage. So at this point, the 1, we're going to find state 1 and find the lowest cost here, which is going to be 700. So we add that on, plus 700. And that's a value here of 1,700. So we'll just write that in, 1,700. And then we'll work through this option here, 2 in storage, £200. Plus I'm making 3, so overheads and additional help, so 300 plus 500. And then from here, at state of 0, and carry on, find the lowest cost there, plus 900. And that gives a total cost of 1,900. So I'll put that in, 1,900. Now there are no other options for this state, so I'll take my lowest cost, and that's going to be 1,900. Sorry, 1,700. The next state we're going to look at is if we have 1 in storage from the previous month. Now to meet December's demand, I need to make 4. Now I can't make any more than 4, and I can't make any less than 4. So for this state, this is the only action that I can take that will meet December's demand, but I won't have any to put into storage. I've got no options if that's the case, if only one has been made in the previous month. So I have the storage cost of that one clock, which is going to be 100, plus making 4. That's my overheads, plus the additional help that I need. Then if none are carried forward to the previous stage, that I look at my previous cost, and that's going to be plus another 900. So that's going to come up to 1,800. So I'll put that in, 1,800. Since this is the only option we have for this state, this is going to be the only value that we can choose, the minimum value, because there is only one value. Now this completes all the options for December. We can't have no clocks in storage from the previous month because we're not going to be able to make 5 in December. We can only make 4 in total, so we must have at least 1 from the previous month. So that completes stage 3. Stage 4 is November. Right, so for November we could have 2 in storage from the previous month. We need to think about how many clocks, what's the maximum amount of clocks I can make in November. Well, let's say I made 4 clocks in November. I would have 6. I only need 3 in November. That would mean putting 3 into storage, but I can't put 3 into storage. The maximum I can put into storage is 2. So if I've already got 2 clocks already, and I can only put 2 into storage, actually the maximum number of clocks that I can have in November altogether from previous clocks and what I make is going to be 5, because 3 of them will get used up and 2 that I don't use will get put into storage. I can't have any more than that, so I can't make 4 because I'll have too many, because only 3 of them are going to get used, and I can only put 2 in storage. And I could also got 2 from the previous month. I could make 2. That fulfills November's demand. I will have 1 excess which I can put into storage. Now you might be thinking at this point, well, what if I just make 1 and fulfill November's demand and have 0 to put into storage for December? But you can see for December that I need at least 1 in storage. I can't have none in storage at the end of November. I need to have at least 1 because the states going into December are 1 and 2, so the destinations leaving November can only be 1 and 2. So now I'll work out the costs. So November, 2 in storage. I'm making 3, so my overheads plus my additional costs, and if I then carry those 2 units in the destination into December, that's going to be 1,700, and that gives a total cost of 2,700. So put that in, 2,700. And for this option here, storage 200, overheads 300 because I'm only making 2, and then the destination's 1, so I add another 1,800, and that will give me 2,300. So for this state, the lowest cost is, or value is 2,300. Moving on to where I have 1 in storage from the previous month, I can make 4, that'll give me 5 in total. 3 of them get used up in November, I'll pass on 2, or I can make 3, so I've got 4 in total. 3 of those will get used up and I have 1 to pass on, Remember, I can't pass on no storage items onto December. It has to be 1 or 2. So we'll work out these costs here. So we will have storage cost 100 plus overheads plus additional help because we're making 4, and then 2, that will be adding on another 1700. So altogether that gives us 2600. Then the other option is going to be storage cost, overheads, additional help because we're making 3, and then 1 in that destination passed on to that state. 1 is going to be 1800 that we add on, and that gives a total of 2700. Then the last option that we have is that no clocks are in storage from the previous month, and then we can make 4. We can only make 4, a maximum of 4, which means we will have enough for November, but we must pass on 1 to the next month. So this is the last state and option that we have. And with this option, there are no storage costs, but there is overheads and additional costs, 300 and 500. And then if we carry this one forward to here, the cumulative cost so far 1800. So we'll add those up, and I think that gives us 2600. So I do need to keep up with the stars. So this state here, minimum is 2600, and for this state here there is only one cost, so that's the minimum, 2600. And we now move on to the last stage, stage 5, which is October. Now remember, no clocks are in storage at the beginning of October, so it's going to be a state of 0. Now how many do we need in October? 2. So we can make up to 4, and then we can pass on 2 to stage 4. Or we could make 3, have the 2 that we need in October, and then pass on 1 to the November stage. Or we can just make 2 in October, which means we'll have none to pass on, and we can do that because you can see there's an option here where we have none and we make 4 during that month. So these destinations must have a state that they go to. Now we'll work out the total cost for each one. So none of these will have any storage costs because there were none in storage before October. If we make 4, that means we have overheads and additional costs, so 300 plus 500. And then if we're carrying forward 2, we need to add 2,300, because that's the lowest cost, plus 2,300. If we're making 3, we're going to have overheads plus the additional help, and then 1, what's that going to cost us? So 1 here, we're going to add on 2,600. And then lastly, if we make 2, we're just going to have overheads, and then we're passing on 0 onto the next stage, so the only cost there is the 2,600. So the totals now become, for the first one here, 3,100. Put that in, 3,100. For the next state here, this is going to be 3,400. Or for the next option, 3,400. And then for the last one down here, that will be 2,900. So we're looking for the minimum cost, and that's going to be this one, the 2,900. So now let's trace this route back. So our minimum cost is here, with 2 being made in October, but none to carry forward to the next month. So it's going to be a minimum cost here, and then 4 being made in November and 1 being carried forward to the next month. So it's going to be this bit here, with 4 being made in December and none being carried on to the next month. So that's going to be this one here. And then lastly, 4 being made in January, with 1 being carried forward to the next month. And that's going to be this one here. So putting that all in words, you want to make 2 in October, which is here, make 4 in November, another 4 in December, another 4 in January, and rest you don't need to make any in February, and that will be a cost of £2,900. Now looking at part B, it says the clockmaker's helper needs some extra income in October. So the clockmaker decides he will definitely make 4 clocks this month. Given this information, use your table to determine the optimum production schedule for the remaining months and write down the total production costs. So I've unhighlighted it because the route's now going to change. We're now making 4 in October. So we're now here, so I can see the cost straight away. It's going to be slightly higher, 3,100. Let's take this route back and see where it takes us. So 4 this month and then 2 carried forward to the next month. So we're looking at this row here, and then 2 made this month, 1 carried forward to the next month. So that's going to be this row here in the table, so just highlight that. 4 made this month in December, none carried forward to the next month, so that's going to be this row here. So I want to highlight in the right colour this section, none carried forward, and here 1 carried forward to February, and so that's going to be the very top row of the table here. So what that's going to mean is 4 in October, so we look at the action columns, how many we're making. 2 in November, 4 in December, 4 in January, and again none in February. And that new cost will be the slightly increased cost here of £3,100. Example 9. A builder has purchased a site and will build 3 houses, A, B and C, on it at a rate of 1 per year. The profit made on each house will depend on site accessibility, interest rate and cost of materials and labour. The builder's estimates of potential profits are shown in the table below in thousands of pounds, so this table here. Dynamic programming is used to determine the order in which the houses are to be built so that the minimum profit in each year is to be maximised. The minimum profit is to be maximised. So this is going to be a maxi-min problem because we want to find the maximum of this minimum profit. What's the maximum minimum profit? Starting with part A, what we need to do is explain the meaning of stage, state and action in this context. So stage, this is how many houses are left to build. The state, this is the number of houses that have already been built. And the action, this is the number of houses that are going to be built. And part B, find the order in which the houses should be built and the value of this minimum estimated annual profit. So this is dynamic programming again. So let's start with stage 1. And stage 1 is going to be like the final stages. So we could have a state of A, B, which means basically that stages A and B have been done, which means that stage C needs to be done, or stage A and C could have been done, and then that leaves stage B to be done last, or action B to be done last. And we could have B and C in terms of a state, which means that in houses B and C have been done, which means that leaves house A to be done. Now, in all three of these cases, the destination will be that all three houses have been completed, A, B and C. So now we'll find the values. So if we have houses A and B and we need to complete C, that action is going to be 80, and these are in thousands of pounds, so this is £80,000. I'll just write it as 80. And if we've completed houses A and C, and we're going to be complete house C, that's going to be 60. And let's keep it consistent with the colours that I've used, 80 and 60. And if I've completed houses B and C, house A, that's going to be 70. So each one of these states only has one option, so they're all going to be the minimums. We're going to be finding the maximum of these minimums. So now we're going to move on to stage 2. Now in stage 2, a house is already going to have been completed. That's either house A, B or C. Now if house A has been completed, then our next step would be to complete either house B or C. If house B has been completed, then our next action is going to be complete houses A or C. Or if house C has been completed, then our options are going to be to complete house A or B next. That will leave us with these destinations: AB, AC, AB, BC, AC or BC. Okay, so since this is a maximum problem, we're going to write down the minimums, and then at the end we'll select the maximum of those minimums. So AB, that will be a value of 65, since A has already been built and I'm going to be building house B, so that's 65. And following on AB up here, back to stage 1, that's 80. And I want the minimum of those two, which is going to be 65. House A, already built, and then I'm building house C, that's going to be 60. So I want the minimum of 60, and carrying on AC up here, 60. Well, that's just going to be 60, they're both the same. 60. I now pick the maximum from these two options from this state, and that's going to be 65,000, so we'll start that. Then we'll move on to the next state, state B. And for this one, house B has been built, so we're looking at this column here, and we're going to build A. That will be 65, so min 65, and then AB is 80. So we want the minimum of 65 and 80, which will be 65. And again, in this column, we've built house B, we're going to build C, so that's going to be 70. That's this value here. So min 70, and BC from the previous state is going to be 70. So the minimum of 70 and 70 is just going to be 70. What do we want? We want the maximum of these minimums, and that's going to be the 70. So we star that one, and then we're now going to be looking at this column here, column C, because house C has been built. So if we build C and then we build A, that's going to be 60. So min of 60, and if we've done AC and then we build B, that's also going to be 60. So that's going to be 60, a minimum of those two. And then if I've already built C and I built B, that's going to be 70. So I want the minimum of 70. And BC then followed by A will be 70. So that's 70 and 70. So the minimum of those two is going to be 70. And then the maximum from these two options for state C will be 70. So we'll put a star there. Then lastly, stage 3. Now at stage 3, we start with no houses being built. So we're right at the beginning of the process. So this is going to be none. And our options are going to be that you build house A, B, or C, which means our destinations are going to be A, B, and C. Only one house has been built. So let's work out the minimums of these. So if I start with house A, which where none have been built, that's going to be 50. And then if I go into the next stage with house A, then I pick the value that I've starred, 65. Whoops, in purple, 65. And I want the minimum of those two, which is going to be 50. If I move on to the next one, if I start building house B first, that means that none's been built before it. That's going to be 70. So min 70. If I then take this destination into the previous stage, B, and I look for my starred value, which is 70. So the minimum of those two is just going to be 70. And then if I start with house C without having anything previously, that will be 65. So min 65. And then if I take this destination into the next state or previous state, and then my start value is 70. So my minimum of those two is going to be 65. And I want to pick the maximum of those three, which is going to be the 70. Right, so I've ended up here, so let's highlight our route going back. So house B first, and as we do normally, we follow the stars. So I go back to B, and where did that 70 came from? That came from here. So C, so let's highlight it so it's nice and clear. Okay, and then the BC, okay, where that 70 came from? It came from this star here, so we'll highlight that. So now I have my house building order and the my maximum value. So house B first, followed by house C, followed by house A, and that will give me a maximum minimum profit of 70, and this is in thousands of pounds, so £70,000 is the maximum minimum profit. Example 10. Toby has a fairground ride and will take it to 3 county fairs over the next 3 weeks. He will leave home at the start of week 1 and travel to the first fair, then go to the second fair for the second week, and then go to the third fair for the final week before returning home. There are 7 fairs during the next 3 weeks, so there is a choice of fair each week. Toby must decide which one of the fairs he should go to. Table 1 gives, and that's table 1 here, gives the week in which each fair is held. Table 2, that's this table here, gives the expected profits in hundreds of pounds in going to each fair. Table 3, this table down here, gives the travel costs in hundreds of pounds. Toby wishes to maximise his income. Use dynamic programming to determine the fairs he should go to and his total income. Okay, so I've got my table ready. It's worth noting what stage, state, action and destination mean in the context of this question. So the stage is the number of weeks that he has left. The state, this is going to be the fair that Toby is currently at. The action is going to be Toby's next journey, and the destination is the fair that Toby will next attend. So remember, dynamic programming, we work backwards. So we look at where he's going to finish. So that's going to be either fair F or G, and from fair F or G he's going to go home. So F or G, the only options is that he goes from that fair to where his home is, and his destination is going to be home in this stage. Now we're going to work out the value. Now if he's at fair F, he's got a profit of 14, and this is in hundreds of pounds, £1,400. So write down 1,400. However, there's probably going to be some costs. Let's see. So what are these travel costs to get from F to home? £800. Right, so we're going to have to subtract 8 from the 14. So 14 minus 8 is going to be 6. Now we are trying to maximize his income. Since there's only one state here or value for this, that's going to be his maximum income. And if he is at fair G, which is going to be here, that'll be a profit of 12. That's 1,200. However, there is going to be a travel cost. So 12 minus, now what's his travel cost if he's going from G to home? That's going to be this one here. That's 7. So it's going to be 12 minus 7. And that will give a value of 5. And again, that's the only option for this state. So that's going to get starred as well. So now we move on to stage 2. So we're now looking at week 2, and we're going to look at what his options are. So he could have been, or he could be at fair C, and from fair C he can move on to F, or he can move on to G. Or he could be at fair D and he could move on to F or G again. So let's write that down. The action is like his movement, his journey. So he could be at fair D and he goes to G, so he'll finish at G. or he could be at fare E and his journey is from E to F or E to G, so he finishes at F or G. So I'm going to start by writing down the profits from each of the fares. So if he's at C, his profit's going to be 8, so I can write that down. There may be some stuff I need to add or subtract from this. If he's at fare D, profits are going to be 10. And if it's fare E, the profits are going to be 11. So now we're going to subtract his travel costs, which we'll get from this table. So these are all going to be minus here. So if we start with the first one, travelling from C to F, that's going to be 5. Subtract 5. Travelling from C to G, that's also going to be 5. Travelling from D to F, that's going to be 4. Travelling from D to G, that's going to be 2. Travelling from E to F, 4. And travelling from E to G, cost of 1. And then we're going to add on the values now from the states F and G. So where it's a state of F, it's going to be a value of 6. So I'll need to add 6 to all the ones that say F. Whoops. And all the ones that say G, I'm going on to G, that's going to be a value of 5, which I need to add on. So now we can work out what the final values are for each one. And that's going to be 9 for the first one, 8 for the second one, then 12, and then that's going to be 13, and it can be 13 again, and then the last one is going to be 15. And as we've done before, for each state we need to be looking for the maximum value. So we need to star the 9, we need to star the 13, and then we need to star the 15 here. Then we can move on to stage 3, which is actually week 1. So let's put that in 3. And during that week, he could be at fare A, and then from A he can move to C, he can move to D, or he can move to E, or he could be at fare B, and then he could move from B to C, B to D, or B to E. I've put in the profits for fares A and B. I've now put on or taken off the travel costs, 325, 133, 325, 133, and I've added on the maximum costs from the previous stage. These are the final values here, and I want to find the maximum for each state. So state A, the maximum is going to be 17. For state B, the maximum is also going to be 17. And then lastly, the last stage 4, we go right back to him being home. And from home, he can go to fare A, or from home, he can go to fare B. So there's no profit from home, but there's a travel cost from home to A or B. So the travel cost from home to A is 3, so that's going to be minus 3. And the travel cost from home to B is 2, so it's going to be a minus 2. and then from here we can then work back and follow the stars. So home to A, we would then go to D, because that will give us a maximum of 17. So minus 3 plus 17 is going to give us 14. And then B, if we would then go on to this route here, which would then be also adding 17, and that gives 15. We pick the maximum of those two, which is going to be the 15. So let's highlight his route. So he starts from home at the bottom, and he's going to go to B. So let's highlight that. Then from B, okay, so that's going to be up here. Where does he go? He goes on to E, because that's the one with the star. So we'll highlight that. So B to E. Right, where does he go from E? So we go up here. So I can see it's going to be this one here, E to G. So we'll highlight that. So E to G. And then from G, he's going to go home, back home again. So we'll just put here, he goes home, and his total income is going to be this value here. Now remember, this is in hundreds of pounds, so it's going to be £1,500. So you should now be able to do exercise 5C on pages 172 to 174 of the textbook.